Okay, in our last video, we talked about factoring trinomials. But last time, in our last discussion, the coefficient in front of ax squared plus bx plus c, the a was equal to 1. But this time, we're going to talk about the same trinomial, but a can be any number. It's not 1, okay? So, let's do that. Okay, good students derive formulas. In our previous video, we factored a trinomial where a was equal to 1. This time we will factor trinomials where the coefficient is not 1, or the coefficient a is not 1. Ax squared plus bx plus c is a trinomial where the leading coefficient a is not 1. For example, these are two factors, and as you know, as from our previous discussion, what a factor is a term inside a multiplication procedure. So we have 2x plus 5 times 3x plus 1. So let's multiply that out. So we have 2x, we have first term times first term, first term times second term, second term times first term, second term times second term. So we said 2x times 3x, 2x times 3x, plus 2x times 1, plus 2x times 1, plus 5 times 3x, plus 5 times 3x, plus 5 times 1, plus 5 times 1. And if we do the multiplication, we have 6, 3 times 2 is 6 times x squared, plus 2x times 1, plus 3 times 5 is 15 times x, plus 5 times 1 is 5, okay? And if you'll notice here, in our equation, m and n, if you remember from our last video, the two terms on the inside that make up b are m and n, okay? And 2 times 15 is 30, and you'll also notice our leading coefficient a and our trailing coefficient c. A times c is also equal to 30. That's 5 times 6. Okay? So that's the difference when we have a is not equal to 1. Okay, let's continue. So we have, previously we had x squared plus bx plus c, where a was equal to 1. There's a 1 right there. Okay. So what we did was, we factored this equation and we came up with x plus 2 times x plus 3. Okay. Where a is equal to 1, we have m plus n equals 5, and c equals m times n equals 6. Okay. M is equal to 3, and m is equal to 3, and n is equal to 2. So to determine those, we had to determine m and n, find the factors of c, which is 6, and use a guess and check strategy to find which pair of factors has a sum of b. So we had to find factors of 6, which was, let's say, 3 and 2. So 3 times 2 is 6, but if you add them, m plus n, 3 plus 2 is equal to 5. So therefore that's our factors. Now we have a is not equal to 1. Okay? So what we'll do is we have 6x squared plus mx plus nx plus 5. Okay. Okay. And so now to find two numbers, m and n, same two numbers, m and n, whose product is equal to a times c, which is 5 times 6, which is 30, and whose sum is 17. Use a guess and check strategy to find which pair of factors has a sum of m plus n equals b. So we're still using the m plus n, but this time we're using a times c as our factor of 30. Okay, so our multiplication is of 30. Previously, we used just C to find those M and N, but now we're using A times C to find the M and N. Okay, so to find these factors of 30, we say, what are factors of 30? Well, 1 times 30 is 30, so 30 plus 1 is equal to 31, and we're looking for a B of 17. 2 times 15 is 30, that's factors, but when we add 15 and 2, we get 17, and that's what we're looking for. Okay? So let's continue. So we have our original equation here and our factors, original equation and our factors. Okay, so 6x squared plus mx plus nx plus 5. And we see here that our factors of 30 that fits our equation is 2 and 15. So we plug in our 2 and our 15. Okay. So what we do is we group the terms with common factors. Okay, and so we group 6x squared plus 2x, and we group 15x plus 5x, 5. Okay. Now, it wouldn't matter if you grouped the 15 over here and the 2x over there. You'll see that it won't matter. Okay. So then we take out the common factors, which is 2x here. So you take a 2x out of here, that's 2 times 3 is 6, and x times x is x squared. And we take a 2x out of here, so 2x times 1 is 2x. And over here we take out a 5, which is a common factor, which is 5 times 3 is 15, and 5 times 1 is 5. So it's 3x plus 1, and there's a 3x plus 1 there. So now we got to factor that out. And we factor that out, and that leaves 3x plus 1 times 2x, which is there, 3x plus 1 times 5, which is there. Okay. So 3x plus 1 is a common factor. Okay. Okay, let's continue. So our factor is 7x squared plus 22x plus 3. In this trinomial, a equals 7, b equals 22, and c equals 3. We have, as we see, our a in our trinomial is not equal to 1. So we need to find two numbers whose product is 7 times 3, which is 21, and whose sum is 22. Make a list of the factors of 21 and look for their pairs whose sum is 22. Okay. The factors of 21 is 1 times 21 is 21, and 21 plus 1 is 22, so we got it on the first shot. Okay. So m is 1, and then n is 21. And it doesn't matter whether you call m or n 1 or 21. It doesn't matter. So m plus n equals 1 plus 21 equals 22. M times n equals 21. And a times c equals 21. Okay. So we write out our equation. 7x squared plus 22x plus 3 equals 7x squared plus mx plus nx plus 3. Write out the pattern. Okay, then we insert m equals 1 and n equals 21. So 7x plus m is 1, x plus 21, x plus 3. Okay. Then we group terms with common factors. Okay. And then we factor out x here. So x times 7x is 7x squared, so that's the x there. And x times 1 is x, so then we factored out the x. We factor out a 3 from 21 leaves 7, and a 3 from 3 leaves 1. So, okay. Then here, now we have a factor of 7x plus 1, 7x plus 1. So we factor that out. And that leaves us 7x plus 1 times x plus 3. Okay, and that's our two factors. And if we multiply that out, those two factors, we should come up with our original equation. Let's try another. Our equation is 10x squared minus 43x plus 28. In this trinomial, A equals 10 and B equals 43 and C equals 28. You need to find two numbers whose product is 10 times 28, 10 times 28 equals 280, and whose sum is minus 43. Make a list of the factors of 280 and look for pairs whose sum is minus 43. So we got the factors of 280, and we start out with minus 1 times minus 280, and we add those together, we get minus 281. Well, we're looking for minus 283. We have minus 2 times minus 140, and that's equal to, we add those, is minus 142. You'll notice that how I got 2, I started with 1 and 280, then I went to 2. How did I get 140? Well, I divided 280 by 2. How did I get 70? I divided 140 by 2. How did I get 70? I divided 70 by 5. Okay, and I got 56. I divided 140 by 4 and got 70. And so that's how I did that. Okay. And so if I walk through these factors, I'll get down to 8 minus 8, and I'll get down to minus 35. So if I minus 8 times minus 35 is a plus 80, 280. Okay, minus 8 times minus 35 is a plus 280, which is what I want. Okay, and if I add minus 8 and minus 35, I get minus 43, which I need. Okay, so let's continue. So I write out my equation, 10x squared minus 43x plus 28 is equal to 10x squared plus mx plus nx plus 28. Write the pattern. Then I insert my m and n. And we said m is equal to minus 8 and n is equal to minus 35. Okay. Then I group terms with common factors, and I factor out 2 and x. If I factor 2 from x, that's 2 times 5 is, if I factor 2 from 10, 2 times 5 is 10, it leaves 5. X from x squared leaves x. And 2x from 8x leaves 4. Okay, 2 times x times 4 is 8x. And I factor out 7 from 35, minus 35 leaves minus 5. And 7 from 28 leaves 4. Okay, I factored out the greatest common factors. Okay, so now that leaves me 5x minus 4 and a minus 5x plus 4. Well, I need to factor out a minus 1 here. So if I factor out a minus 1, that changes 5x to plus and 4 to minus, and my 7 to minus. Okay. So then now I factor out 5x minus 4, 5x minus 4, and that leaves me with 2x plus 7, minus 7, 2x minus 7. Okay, and these are my factors. Okay, let's check our work. Here's our factors that we came up with, and we say that should be equal to that. So let's multiply that out. 5x times 2x, 5x times 2x, plus 5x times minus 7, 5x times minus 7, minus 4 times 2x, minus 4 times 2x, minus 4 times minus 7, minus 4 times minus 7. And then we do the multiplication. 2 times 5 is 10, x times x is x squared. 5 times minus 7 is minus 35x. Minus 4 times 2 is minus 8x. And minus 4 times minus 7 is plus 28. And then we add up our middle terms. We get 10x squared minus 35x minus 48 is minus 43 plus 28. And that is our original equation. And so our work checks. Zero product property. If the product of two factors is zero, then at least one of the factors must be zero. So here's our original equation. So we want to rewrite our equation so that one side equals zero. Okay. And now here are our factors that we came up with before. Okay. So if they're equal to zero, at least one of them or both of them are equal to zero. So what I do is I set them both equal to zero and solve for x. And the solution set is 4/5, x is 4/5, and x is 7/2. Okay. Let's check that. So we'll plug in x for 4/5 into our equation, and we see we get minus 28 minus plus 28 equals 0 equals 0. And that checks. And we'll plug in 7/2 into our equation, and you'll see we do the multiplication, we get 0 equals 0. And so that checks. So both our answers check. So x is equal to 4/5 and x is equal to 7/2. Let's try another. Okay, in this trinomial, a is equal to 3, b is equal to 24, and c equals 45. So you need to find two numbers whose product is 3 times 45 is 135, and whose sum is 24. Make a list of the factors of 135, and look for pairs whose sum is 24. Okay, and we did that, and we worked through these. I started out at -1, and when I got down to 9, I just divided 9 into 135. That comes out to 15. Okay, so 3 into 135 comes out to 45. 5 into 135 comes out to 27. That's how I did that. So when I add these together, I get 9 plus 15 is 24, and that's what I'm looking for. Okay, so I call m equals 9 and n equals 15, and I add them together, I get 24. M times n is 135, and a times c is 135. Okay, let's continue. So what I do is I insert my m and my n, 9 and 15, and then I group the terms with common factors, and then I factor out the greatest common factor. So here I have 3's I can factor out, and x's I can factor out. It's okay. So that leaves me 3x times x plus 3. Here I got a 15 I can factor out, and a 15 from 15x leaves me x. 15 from 45 leaves me 3. So I have 3x times x plus 3 plus 15 times x plus 3. Well, x plus 3 is a factor. I can factor it out. Okay. So if I factor x plus 3 out, that leaves x plus 3 times 3x plus 15. Okay. Now, I can still factor out from 3x plus 15, I can factor out a 3. Okay. So I factor out a 3, and that leaves me 3 times x is x. 3 times x is 3x, and 3 from 15 is 5. So that's 3 times x plus 5 times x plus 3 right there. And that's my factors. Okay. Now here's our same equation we had previously. But this time, I noticed that I can factor out a 3 in the beginning. Okay. So that leaves me 3 times x squared plus 8x plus 15. Okay, I factored out the greatest common factor. Now, the a is equal to 1. Okay, since the lead coefficient a equals 1, find two factors of 15 whose sum is 8. Okay, since we're dealing with a equals 1, we find two factors of 15 whose sum is 8. Okay. And then we do factors of 15, 1 times 15 is 3 times 5. If we add 3 times 5, we get 8. See, we're dealing with this equation here, not this one where the a is equal to 3. We factored out the 3. So now we're dealing with the second equation here. x squared plus 8x plus 15. So we add, multiply 3 times 5, that's 15, and we add 3 plus 5, we get 8. Okay. So we insert our m and n right here. We insert our m and n, and then we still have our 3 factor out here. Then we factor out common factors, x times x plus 3, subtract out of 5 times x plus 3. Then we factor out x plus 3 times x plus 5 times 3. And that's our factors, okay? So we did this 2 ways, in 2 methods. Okay, does factoring always work? Let's see. 2x squared plus 5x minus 2. In this trinomial, a equals 2 and b equals 5 and c equals minus 2. You need to find 2 numbers whose product is 2 times minus 2 is minus 4, and whose sum is equal to 5, the middle term. Make a list of the factors of minus 4. Look for pairs whose sum is 5, okay? And that's what I did. I went through here and I made a list of the factors of minus 4. And guess what? I couldn't find any factors that would add up to 5. There are no factors of minus 4 whose sum is 5. Therefore, this equation cannot be factored using integers. To factor this equation, you will need the quadratic formula. And that's what I'll do next time in our next video. So until next time, I hope you learned something. And I hope you learn mathematics. You love mathematics. Good students derive formula. That is, they just don't memorize.